Welcome back to my YouTube channel. And in the previous video we covered Form 3 Chapter 1 Indices, and we mainly covered the understanding part of it, like what is indices and an introduction to it. In this video we will be focusing on the laws of indices and the essentials you have to know if you want to solve any questions related to indices. Without any further ado, let's begin. So in the case of law of indices, we have mainly 8 laws. As you can see in the screen, we have 8 laws, and I'll be going through all of them one by one. So stick with me, and I assure you it's not as difficult as it seems. I will also prove to you why these laws are valid. In that way you can have a better understanding of how it actually works. So a brief refresh for those who have not watched the previous video. In a form where a to the power of n, we can say that a is the base number, which is the number that is being multiplied. Then n is the number of times the base time, which is a in this case, is being multiplied. If you feel that it's a bit complicated to understand, I would highly recommend you to watch the previous video where I went in detail with few examples. But here I'm going to straight away get into today's topic. So here, viewing the algebraic equation in the algebraic form may be a bit confusing. So to solve that problem, we are going to use numbers. So let a be 2. It's going to be 2 for the whole video, and then m is going to be 6 and n is going to be 3. Alright, that seems good. So if you're going to substitute those numbers inside this very equation, we're going to have 2 to the power of 6 times 2 to the power of 3 equal to 2 to the power of 6 plus 3. So here we have 2 to the power of 6 times 2 to the power of 3, and it's equals to 2 to the power of 6 plus 3. To give a visual explanation, let's just write out what is 2 to the power of 6. It's just 2 multiplied by itself 6 times. 2 times 2 times 2 times 2 times 2 times 2. And then what is 2 to the power of 3? So 2 to the power of 3 is just 2 times 2 times 2. So if you count the number of 2's that we have right here, we will get a grand total of 2 to the power of 9, which is the same as 2 to the power of 6 plus 3. If you imagine it, it's quite simple actually. 6 is the number of times a number is being multiplied to itself. So when you times two numbers the same base, you are essentially adding the number of times the first number is multiplied together the second number is multiplied. So in the first number we have 6 multiplied as 2 multiplied 6 times. Then in the second number we have 2 multiplied 3 times. So add them together, you get 2 multiplied by 9 times. That's it. It's as easy as that. Nothing to complicate about. That's why 2 to the power of 6 times 2 to the power of 3 is equals to the powers added together. In this case, 2 to the power of 9. That is the first law. Moving on, let's go to the second one, where we have the second law is a to the power of m divide a to the power of n is equivalent to a to the power of m minus n. So I'm pretty sure you can understand that it's just the counterpart of the times of the multiplication law. Here we're just subtracting it. But for the sake of explanation, I will still be using the same variables. So a is 2, so we have 2 to the power of 6 divided by 2 to the power of 3 equals to 2 to the power of 6 minus 3. So here, for a better explanation, I will be writing down in the fraction form. So 2 to the power of 6, as we know, 2 to the power of 6 divide can be written down in a fraction form as over 2 to the power of 3. So here we are going to list down all of the 2's that we have in the index notation. So 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. We have 6 on top, then we have 6 at the 3 at the bottom. So as you can see, we have 6 2's at the top and then 3 2's at the bottom. Pardon me, that's not a 3, that's 2. So here, in any fraction, we can simplify the numbers if they are same, or if they belong to the same multiplication table. We can just cut them. So 2 gone, and then 2 gone. And here, what we have left is nothing at the bottom, so which is 1. Then we have 3 2's at the top. So 2 times 2 times 2. In index notation, it will be equivalent to 2 to the power of 3. If you look closely to the equation we got earlier, 2 to the power of 6 minus 3, it's also 2 to the power of 3. It's as simple as that. If you can visualize times in the form of just adding the number of times is multiplied together into a sum, that's for multiplication law. And then for divide, just remember it in the fraction form. Once you start to make sense of it, it will become more natural to you. Right, that's the first two laws, the multiplication law and the division law. The next we have is the power law. A disclaimer, the names of the laws I'm using are just for understanding. If you like to know the actual name for the laws, be sure to refer to your textbook. So, number 3, we have we have a to the power of m in bracket to the power of n is equal to a to the power of mn. So here you can see the first one was addition, second one was subtraction, third one is multiplication. So to make you understand this, I'm going to use the exact same variable. It is 2 to the power of 6. 3 is equals to 2 to the power of 6 times 3, which is 18. So what's happening here? So as we know, the power means it's being multiplied by itself 3 times. So from this we can say that the whole 2 to the power of 6, the whole thing here, is being multiplied to itself 3 times. That's the meaning. So this can also be written as 2 to the power of 6 times 2 to the power of 6 times 2 to the power of 6. As you can see, this is how it works. So since we know the first law, which is times with the same base number, we can just add the powers together. So here we can just add 6 plus 6 plus 6. We get 18. And that's it, as simple as that. That's why a to the power of m, the whole thing to the power of n, is the same as a to the power of mn. And that's the third law. Now, moving on to the fourth law. The fourth law is an interesting one. When we let me say the fourth law. Fourth law is a to the power of 0 is equivalent to 1. This one is an interesting one. I'll tell you why. When you have one number, for example, a to the power of 1, so let's use 2 to the power of 1. So 2 is being multiplied to itself 1 time, so it's just 2. So it's nothing, it's just 2. So 2 is multiplied by 1 essentially, so 2 is just 2. So when you have 2 to the power of 2, we have 2 multiplied by itself twice, so we get 4. But what if 2 is multiplied to itself 0 times? At the surface, it doesn't make any sense. I understand. But let's try to use mathematical logic to understand why this works. So here we are going to write a fact, which is 2 minus 2 is 0. We all have an agreement on that? I hope so. 2 times 2 is 0. And that's a well-established fact. Anything subtracted by itself will become 0. So here we are going to use the exact same concept. So let's put our number 2 here, and then since 0 is written here, so we are going to write 2 to the power of 0. And as you can see from here, we have established that 0 is equal to 2 minus 2. So here we can write 2 to the power of 2 minus 2. So according to the second law, when we see minus in power, it is division. Is that correct? Yes, it is. So we can write this out as 2 to the power of 2 divided by 2 to the power of 2. So if you, for better visualization, let's write this in fraction form. 2 squared divided by 2 squared. So here, 2 squared divided by 2 squared, if we break it down even more, we will get 2 times 2, 2 times 2. So in this fraction form, we are free to cut the numbers. So 1, 1, 1, 1. As you can see, we are left with 1. This is true for every single number, any single real number there is. Starting from all the positive numbers and all the negative numbers. Anything to the power of 0 will give you 1. So just remember that. So if anyone wants you to prove this equation, just show this. This is plenty of proving. So now the fifth. So the fifth one is something that is known as reciprocal. Reciprocal is anytime you put a number in fraction and add 1 on top of it. So let me show you what I mean by that. So when we say a to the power of negative 1, a to the power of negative 1, yes, the power is in negative, but it does not mean that there's a negative, that a becomes negative. No. When a is a to the power of negative 1, we will write it down as 1 over a to the power of 1. Let that sink in. So for instance, if we have the number 2 to the power of negative 2, what will happen is we will put a 1 on top of it, and at the bottom we will have 2 squared. This negative symbol will vanish at the bottom, it will become positive. And for those who would like to remember it this way, it is also possible. This minus becomes elongated and becomes the fraction symbol at the top. Just for understanding, that doesn't happen that way, but just for understanding, it's completely fine. So that is the fifth one. So let's move on to the last 3 laws that we have. And this law is, what if we have a fraction in our power? We have a fraction number in our power. For instance, we have a to the power of 1 over n is equivalent to what? This is where we are introduced to the square root in the index notation. For better demonstration, I will use the numbers. So a is 2, then n will be 3, as we have mentioned before. So this will be the cube root of 2. So just remember, when it's a positive number, it's just normal. When there is a negative number, it becomes the reciprocal. And when it is a fraction in the power, it becomes the root. It can be square root, cube root, it can be the root of 4, root of 5, and so on. It can be anything. But just remember, when there is just a number, it is going to be normal. When there is a negative symbol, it becomes the reciprocal. And when it's a fraction, it becomes the root. And then up next, we're going to the last 2 laws are more of a combination of the previous 2 laws that we have learned. so it shouldn't be much of a difficult task. So here we have a to the power of m over n. So this can be written as a to the power of m in bracket 1 over n. If you see closely, this ties into what we learned in the power rule, where when a to the power of m, the whole thing to the power of n, a to the power of m, the whole thing to the power of n, when it's combined, it becomes a to the power of mn. The same concept applies here. So m over n, if we separate it into 2, we get m times 1 over n. So we can also write this in the form of a to the power of 1 over n to the power of m. If you see carefully, it's just rearranging and scrambling the order, but essentially the concept is the same. Then it can also be written in a different form, where we can write it in root form. So we can write a to the root of n, the whole thing, to the power of m. Or you can also write it this way. Same thing, but this time put the m inside. If you see, it's the exact same thing, just written in so many different ways. So in examinations, the teacher or the examiner, the person who set the paper, will try to confuse you with this key symbols and key arrangements. Just remember, once you have a good grasp over this concept, this should be easy. So if you are still a bit unsure of how everything works, I would recommend you to watch this video one more time. Not the whole part, I know it might get boring. The parts that you feel a bit uncertain, but don't worry. There's another video coming soon where I will be attempting a few questions regarding this topic, and hopefully that will help you to understand how we approach questions regarding this topic. It will be much easier. Trust me, this topic is very interesting. I won't say it's easy, but it's one of the most interesting topics that you will ever see. And those are the eight laws that we are going to cover in this video. First one is a to the power of m times a to the power of n is equals to becomes plus. When the same base number with the different powers divide, it becomes minus. When a base number to the power of m and the whole thing to the power of n, just multiply. A to the power of 0 is always 1. A to the power of negative n becomes the reciprocal. A to the power of a fraction becomes root. Then the last two are just combinations that we get from the 6th law. So these are the laws that build the core, these are the backbones of this entire topic. So make sure you understand them, and I will meet you in the next video where we will be doing questions, and hopefully you understand from that. So till then, have a good one. Signing off is Rishi. Bye bye.